What if the air you're breathing right now could solve world hunger?
Every plant on Earth needs nitrogen to grow green and strong. Our atmosphere is 78% nitrogen gas, N2.
But N2 is locked by a powerful triple bond, nearly impossible to break. For thousands of years, farmers faced this cruel paradox.
By 1900, scientists warned of global famine within decades. One German chemist, Fritz Haber, asked a revolutionary question.
What if we used immense pressure and heat to force a reaction?
The answer was ammonia, NH3. The key to unlocking the atmosphere. This simple molecule, NH3, would become history's most important chemical.
But how do you turn a lab experiment into a world-feeding machine?
The process needs two ingredients from opposite sources.
Giant machines cool air to -200 degrees Celsius. Natural gas and steam are torn apart at 800 degrees. These purified gases mix, then face a crushing 200 atmospheres.
200 times the pressure at sea level. Stronger than ocean depths.
This super-pressurized cocktail feeds into the reactor's heart. Inside, at 450 degrees Celsius, magic happens. An iron catalyst provides a stage where nitrogen's bond can be broken.
The iron weakens the bond, allowing hydrogen atoms to attack.
Hydrogen atoms bond one by one, building ammonia, NH3.
But here's the catch. In one pass, less than 20% converts.
So the process uses a brilliant trick: separation and recycling. The mixture is cooled. Ammonia liquefies first at -33 degrees.
Liquid ammonia is collected. The leftover gases are not wasted.
They get pumped right back in, getting infinite chances to react.
Though each pass yield is low, continuous recycling gives near 100%. The final product is stored as a clear, pungent liquid under its own pressure.
From here, it travels to every corner of the globe by truck, train, and ship.
This chemical, NH3, becomes the foundation of our global food supply.
Most ammonia becomes solid fertilizers: urea, ammonium nitrate, ammonium sulfate.
Or it's injected directly as a gas, where plant roots can use it immediately.
The result? Crop yields exploded, multiplying up to 5 times over. This allowed food to keep pace with booming 20th century population. It created unprecedented abundance and made food affordable for billions.
It empowered small farmers everywhere to feed their families and communities. But this power had a dark twin. The same chemistry makes explosives.
Ammonia's uses exploded: refrigeration, plastics, cleaning, pollution control. Yet, the Haber process has a significant environmental cost.
It consumes 2% of world energy and produces massive CO2.
Excess fertilizer runoff creates dead zones in lakes and oceans.
Now, scientists race to reinvent the process for a green future.
Using renewable power to make green ammonia with 0 emissions.
This green ammonia could fuel ships, replacing dirty fossil fuels.
The challenge: sustain the benefits while healing the environmental costs.
The Haber process is in the bread you eat, the clothes you wear, our world.
Haber and Bosch won Nobels for perhaps humanity's most important invention.
It's estimated, without it, over 3 billion people might not exist.
A monument to ingenuity, turning fundamental science into an Earth-scale system.
One equation embodying both our creative and destructive potential.
From your morning routine onward, your life is touched by this reaction.
It is the foundation of modern civilization, for better and for worse.
The future lies in partnering with nature's wisdom, not replacing it. The next revolution is precision, feeding plants, not polluting rivers. From air to factory, to soil, to plant, to us, the nitrogen loop of life.
It reminds us that our biggest challenges are solved at the molecular level.
And it asks, what other impossible-seeming problems await our solutions? So, the next time you sit down to eat, remember the secret ingredient. It wasn't grown just in soil. It was pulled from the air itself.
The Haber process. How we learn to feed the world from thin air.